The directions say to find the exact length of a polar curve. So in other words, we are going to be looking for the arc length of a polar curve. In example 1, suppose we are given r equals 2 cosine theta, where theta is greater than or equal to 0 and less than or equal to pi. The formula for arc length is given as follows. L equals the integral from a to b of the square root of r squared plus dr d theta squared d theta. Now, if r equals 2 cosine theta, dr d theta is equal to negative 2 sine theta. If r equals 2 cosine theta, r squared is equal to 4 cosine squared theta. And if dr d theta is negative 2 sine theta, then dr d theta squared is equal to 4 sine squared theta. So if I take r squared plus dr d theta squared, this is equal to 4 cosine squared theta plus 4 sine squared theta. Factoring out the 4, we get 4 times the quantity cosine squared theta plus sine squared theta. But remember, cosine squared theta plus sine squared theta is equal to 1. So this is equal to 4 times 1, which is equal to 4. Therefore, L is the integral from 0 to pi of the square root of 4 d theta. But the square root of 4 is equal to 2. So this is equal to the integral from 0 to pi of 2 d theta. This is equal to 2 theta evaluated from 0 to pi. And so the correct answer here for example 1 is 2 pi. Let's take a look at example 2. Suppose we are given r equals theta squared, where theta is greater than or equal to 0 and less than or equal to 2 pi. Dr d theta is equal to 2 theta. Now, let's keep in mind something. R squared is equal to theta raised to the 4th power. And if I take dr d theta and square it, 2 squared is 4. And so I would end up with 4 theta raised to the 2nd power. R squared plus dr d theta squared is equal to theta to the 4th plus 4 theta squared. And I'm going to factor out the theta squared, and so I end up with theta squared times the quantity theta squared plus 4. And so L is the integral from 0 to 2 pi of the square root of theta squared times theta squared plus 4 d theta. But theta is in between 0 and 2 pi, right? And so keep in mind that the square root of theta squared is equal to theta, where theta, again, is in between 0 and 2 pi. And so, therefore, this is equal to the integral from 0 to 2 pi of theta times the square root of theta squared plus 4 d theta. Let's note something here. The integral of f prime of x times the square root of f of x dx is equal to 2/3 times f of x to the 3/2 plus c. That's a fact. And you can convince yourself with the following u substitution. So if I let u equal f of x, du is equal to f prime of x dx. And if I plug all that in, you will see that you end up with 2/3 times f of x to the 3/2 plus c. Now, let's go back to our original integral. Our original integral is the integral from 0 to 2 pi of theta times the square root of theta squared plus 4 d theta. It almost fits this form right here. Almost, but not quite though. So what I'm going to do is I'm going to let f of theta equal theta squared plus 4. So whatever's inside that radical, in other words. If I take f prime of theta, if I take the derivative of f of theta with respect to theta, I get 2 theta. Well, notice how I have a theta here, but I'm missing a factor of 2. And so what I'm going to do is insert that 2 in, and you can see that in red. But you can't just do that. And so what I'm going to do to offset that is multiply the integral by 1/2. Remember, you can multiply something by 1 and not change its value, right? So keep in mind that if I take 1/2 of 2, I get 1 back, right? So I've changed nothing about that integral. Now, notice here, theta squared plus 4 is right here. The derivative of theta squared plus 4 is right here now. So that's okay. And I could apply the above formula. So what I end up getting is 1/2, because the 1/2 is right here, times 2/3 times the quantity theta squared plus 4 to the 3/2, right here, right? That's a 2. And I'm evaluating that from 0 to 2 pi. So notice how these 2's cancel. And what I end up getting is 1/3 times the quantity 4 pi squared plus 4 to the 3/2. If I factor out the 4 inside those brackets, I end up with 1/3 times the quantity 4 times pi squared plus 1, all raised to the 3/2. But 4 to the 3/2 is equal to 8. That's right here. And so what I end up getting is 8/3 times pi squared plus 1 to the 3/2. And that's how we do example 2. We have to be a lot more careful with example 3. Example 3 is really tricky. Suppose I'm given the polar curve r equals 2 times the quantity 1 plus cosine theta. Now notice I don't have any restrictions on theta, okay? But we can figure out those restrictions. Now, I drew us a little table here to see what's going on. Now, I'm picking values of theta and finding my corresponding values of r. When theta equals 0, remember that cosine of 0 is equal to 1, right? And so when theta equals 0, r equals 4. When theta equals pi over 2, keep in mind that cosine of pi over 2 is equal to 0, unit circle. And so therefore r equals 2. When theta equals pi, r equals 0, so I'm following the same kind of pattern here. When theta equals 3 pi over 2, r equals 2. When theta equals 2 pi, I get r equals 4. So I get back to my original value when I plugged in 0. And so what that told me, since I cycled back, and 2 pi is equivalent to 0, right? So what that told me is that theta is between 0 and 2 pi. dr d theta is equal to negative 2 sine theta. So r squared plus dr d theta squared is 4 times the quantity 1 plus cosine theta raised to the second plus 4 sine squared theta. Now, what I want to do is take 1 plus cosine theta and square it. And so when I do that, I get 4 times the quantity 1 plus 2 cosine theta plus cosine squared theta plus 4 sine squared theta. So this is 4 plus 8 cosine theta plus 4 cosine squared theta plus 4 sine squared theta. Now, remember, I don't want to reinvent the wheel, but we need to recall that 4 cosine squared theta plus 4 sine squared theta is equal to 4. That's from example 1. And 4 plus 4 is equal to 8. And so what we end up getting is 8 plus 8 cosine theta. Factor out the 8, and we get 8 times the quantity, 1 plus cosine theta. So L is the integral from 0 to 2 pi of the square root of 8 times the quantity, 1 plus cosine theta, d theta. And so let's go back. Keep in mind, the square root of 8 is the square root of 4 times 2, right? Square root of 4 is 2. So this is 2 times the square root of 2. So we get 2 times the square root of 2 times the integral from 0 to 2 pi of the square root of 1 plus cosine theta d theta. Now, this is a power reducing formula here, but it's really important in Calc 2. Cosine squared theta is equal to 1 plus cosine 2 theta divided by 2. Okay, very useful for integrating. Now what I want to do is multiply both sides by 2. And when I do that, I get 2 cosine squared theta is 1 plus cosine 2 theta. So I'm going to take theta, it's right here, and I'm going to replace it with theta over 2. And when I do that, I get 2 cosine squared theta. Let me say it again. I get 2 cosine squared of theta over 2 is equal to 1 plus cosine theta. Because remember, 2 times theta over 2, 2's cancel, and we get theta. And so what I end up getting is 2 times the square root of 2 times the integral from 0 to 2 pi of the square root of 2 cosine squared of theta over 2 d theta. The square root of 2 times the square root of 2 is 2. 2 times 2 is 4. Okay? By the way. So, but we'll get to that in a minute. We'll get to that part in a minute. So this is 2 times the square root of 2 times the integral from 0 to 2 pi of square root of 2 times the square root of cosine squared of theta over 2 d theta. But we have to be careful, okay? Now, on the interval from 0 to pi, cosine of theta over 2 is non-negative, right? On the interval from pi to 2 pi, cosine of theta over 2 is negative. And to counterbalance, we have to insert a negative here. We have to be careful. I'll explain that at the end of this video. So I claim we have to break up this integral at pi. And so when I do that, I get 4 times the integral from 0 to pi of cosine of theta over 2 d theta plus 4 times the integral from pi to 2 pi of negative cosine of theta over 2 d theta. Again, I will explain this at the end of the video. Now, from here, this is 8 sine of theta over 2 evaluated from 0 to pi plus negative 8 sine of theta over 2 evaluated from pi to 2 pi. And when I evaluate, I get 8 plus 8, and that's equal to 16. Now, let's explain something here. Let's draw a picture. Here's x, here's y, okay? And we're going to look at the graph of y equals cosine x. I'm going to put a pi over 2 here. I'm going to put a pi. I'm going to put a 3 pi over 2. And I'm going to put a 2 pi. And when I do that, I get the following. Now, this is the graph of y equals cosine x. Now, what I want to do is focus my attention from 0 to pi, right? Now, remember, we're just dealing with x. We're not dealing with x over 2 yet, so keep that in mind. If x goes from 0 to pi over 2, can we agree that the corresponding y value is non-negative, right? If we go from pi over 2 to pi, the y value is negative, right? But keep in mind something. We're dealing with y equals cosine of x over 2. See, if I replace x with pi, cosine of pi over 2 is 0. If I replace x with 0, cosine of 0 is 1. So I claim that cosine of x over 2 is greater than or equal to 0 if x is in between 0 and pi. Okay? Now, you can convince yourself by plugging in 0, right? Plugging in pi, and then picking a value in between 0 and pi. And you will see that y is non-negative the whole time. And then cosine of x over 2 is non-negative if x is less than or equal to 2 pi and greater than or equal to pi. And so if cosine of x over 2 is non-negative, if cosine of x over 2 is less than or equal to 0, if x is greater than or equal to pi and less than or equal to 2 pi, then that tells me negative cosine of x over 2 is greater than or equal to 0 if x is less than or equal to 2 pi and greater than or equal to pi. And remember something. If I don't give you a restriction on x, right, whatever you get has to be non-negative. You cannot get a negative number when you take the square root of this. And because of that, this is how the square root of x squared is defined. It's equal to x if x is greater than or equal to 0. If x is less than 0, okay? And by the way, if you're less than 0, you're less than or equal to 0. That's okay. If x is less than 0, I claim you're going to get negative x. Because if x is less than 0, negative x has to be bigger than 0. Okay, that'll do it for this video. This is a video on arc length of a polar curve. Thank you.